Welcome to episode 1 of the AI for Cybersecurity training series. My name is Hank Hackerson, your instructor for this series. And in this episode, we're going to get a non-technical answer to the question, what is AI? You may or may not already know what AI actually is. A lot of people throw that phrase around, that little term AI around very frequently, and very many of them don't actually know what it is. They don't know what AI is, what it consists of, what it was made of, and really what it can actually do in its grand scheme of things. So that's what we're going to be talking about in this particular episode so that we can set the stage for everything else in this course, because to know where we are going, we need to know where we have been. As I mentioned in the intro, my name is Hank Hackerson, or at least, it's my pseudonym for now. Believe it or not, that's not my real name. And over the next 28 chapters or episodes, if you're watching along, so obviously you're watching along, so if you were reading this, there would be 28 chapters. Since you're watching, there are 28 episodes. We're going to demystify artificial intelligence, also known as AI, and show you exactly how to harness it for cybersecurity, specifically because this channel, after all, is dedicated to cybersecurity and pen testing, ethical hacking, all that good stuff, a little bit of system administration. We can call it IT in general, or maybe computer science, but that's pretty much what I'm going to be leading towards as we go through this training series. But you can also use this content for pretty much AI with anything else. So it doesn't really matter if you're in cybersecurity or not. You can still use this information to integrate AI into a variety of different tools, including robotics, and of course, use it to leverage and elevate your skill set in the marketplace when it comes down to career paths and work and things like that. So all of these things will be available to you even if you're not in cybersecurity or planning to pursue cybersecurity. Whether you're a complete novice who's never coded a line in your life, or a seasoned IT pro looking to level up, this book or this training series is going to be your roadmap. No jargon overload, no prerequisites, just clear step-by-step guidance to make you confident and capable. And in case you're wondering why start here with the basics, because maybe you're just a really amazing tech person and you don't need the basics, but we do have to factor in the fact that there may be people that are not tech savvy that are watching this and kind of entering the tech space for the first time, and it's very overwhelming and kind of scary to think about. That's one answer as to why we start with the basics. But also, AI isn't some distant sci-fi dream. It's the engine that's powering the tools that keep your data safe today, if we're talking about cybersecurity. But really, honestly, once we go through some of the examples, you'll actually kind of be shocked as to how much AI is actually playing a role in your life, and how much it played a role before GPT came out, right? Before ChatGPT first emerged, how much AI was actually influencing our daily lives and security in our lives with our money and our data, all of that stuff. By the end of this video, you're going to know what AI is and what it is not, and you'll also see its fingerprints in your everyday life and understand why it's a game changer for cybersecurity specifically. And we're going to use simple analogies, real-world stories, and a touch of history to build your foundation. And I promise you, this is going to be very quick at the end to lock it all in. And the quiz, there's going to be a quick quiz at the end to make sure that we lock it all in, plus a preview of what's next in the future episodes. And I'm very excited about it. I can't really say enough about how excited I am about it. See, that's how excited I am. I can't even phrase sentences together. I'm super freaking excited. So it's going to be really, really cool. A quick little note from our Hackaholics Anonymous membership community and how you can get access to the book that I'm using for the lecture, how you can get access to all of the downloadables as we further develop this course, and how to get access to me directly. And just in case you are a company that is looking for somebody to hire that can be very effective, I would love to put my name in the hat, so to speak, of anybody that you may be considering. Hint, hint, Elon Musk, if you're considering this, if you're watching this in any way. I'm going to say that name so often in this training series that I hope that somebody, if not Elon directly, somebody will find me and will hit me up, and I'll get a chance to actually work with that team. I'm super excited about it. So anyways, quick little note from Hackaholics Anonymous, and then we will dive deep into it. Let's go. If you want access to my notes and exclusive downloads and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section. So the big question is, what is AI anyway? And the best way that we can deliver this, or answer this question, I should say, is to give you a quick little scenario. So imagine that you're at a massive library, one so big that it holds every book ever written, which is a lot of books, right? And every email that has ever been sent, and every photo that has ever been snapped, every photo that has ever been taken. Now you ask the librarian, what is the best mystery novel for a rainy afternoon? A human librarian might take minutes, probably hours, honestly, to sift through the shelves, to recall recommendations, and chat with you about your tastes, because bias is also a really big deal when you're dealing with a human being, right? But what if the librarian could scan those millions of books in seconds, cross-reference reviews from thousands of readers, and suggest a tailored title perfectly for you? Now, complete with why that book will actually hook you on page 1. How amazing would that be, right? That's AI in a nutshell. It's a super smart system that processes information at lightning speed to help us little humans, make sense of the world. And really, when you think about it, it's pretty much this massive data, like massive database, right? It has scraped everything that exists on the internet. It has scraped every book that exists, probably every image, and every, art. I mean, when I say everything on the internet, it includes the forums and the Reddit posts and Wikipedia and people's individual websites and like everything that exists on the internet. And through that massive data set, it has been trained to communicate with you through a variety of different, layman's terms types of phrasings and sentences. And it can craft all of that in real time, in a fraction of a minute, right? Like few seconds is usually what it takes for any AI model to actually respond to a prompt. And it could be a very complex prompt. Like I have given long, like multiple paragraph type prompts, and it takes maybe 10 seconds to respond with like a really, really well thought out, quote unquote, response. So that's pretty much the power that the average AI tool these days has, right? The average language model, the generational or generative, I should say. I for some reason I can't pronounce that word, but it is technically a chat AI, a generative AI that you are communicating with when you communicate with Grok or ChatGPT or whatever. At its core, AI is about creating machines that can perform tasks requiring human-like intelligence, and it's going to get further advanced. So literally by the time that you probably watch this video, the next generation of AI chatbots and AI models will have been launched, and I think by version 5 of Grok and GPT, it's going to get to a point that it's going to be smarter than any single human being. And by version 6, it'll be smarter than all human beings combined. So when you talk about human-like intelligence, we're talking about ways that it can, combine data and give you a concise response. But really, when you're comparing it to a human being, in 1 or 2 model upgrades, it's going to be significantly smarter than any human being. The intelligence level of your average AI chatbot is going to be significantly smarter than the average human being. So this is one of those things to keep in mind. It's like having like a super genius at your fingertips. And a lot of people still use it to write articles and essays and things like that. So it's mind-blowing what these things can actually do. The idea is not to build robots, right? Robots that look like us. Although if you have been keeping up with what's going on with Elon and Tesla and of course, Optimus, the robot that they have already released, it's coming very soon. The progress is being made very, very quickly, and probably in a couple of years, it'll be commercially available where people can actually have their own robots inside their house. It's insane when you really think about it. Like, we are literally in the future, and 5 years from now, 10 years from now, the world is going to be I fantasize about what the world is going to be like, but it's going to be extremely cool. And there's going to be a lot of really cool elements to it. For example, a personal robot in every household. There's also algorithms to think about. So this whole concept of AI is really about algorithms, which is a step-by-step instruction that's encoded in software. And these algorithms allow computers to learn from data, to recognize patterns, and make decisions. That's where the final piece of it comes in. And this is where a lot of people think that maybe AI will take over humanity. It's like, what if it starts making decisions on its own? And what if it starts taking over our lives and things like that? This decision-making process, or these decision-making abilities that AI chatbots, or AI models in general, I should say, chatbot seems like such a trivial description of it. The decision-making element of it is what people are most afraid of. Is what if it starts to make decisions on its own without a human being prompting it to do so? Think of these algorithms as recipes. So give the AI the right ingredients, which is data, a prompt, right? And it'll whip up solutions like personalized playlists or fraud alerts, or write a book for you, or a script, or generate an image for you, or you name it, really. It can pretty much do anything at this point. And once it has access to the physical world, it will also be able to do anything inside of the physical world. But again, it's one of those things that if we really started looking at some of the examples, which we're going to look at in a little bit, you'll be like, oh, you know what? These things actually do kind of exist already in our world, even in the physical world. So the key piece to keep in mind is that AI doesn't think like we do. And this think portion has been quoted, I don't know if that's a word, on purpose, right? There's a specific reason why this is like this, because the level of thinking that a human being can do is very different to what an AI tool can do. Even though it's like a super genius, the level of thinking that an AI tool can do is very different from human beings. AI does not have consciousness. It doesn't have emotions. It doesn't have free will. It's more like a highly trained apprentice, brilliant at specific jobs, but utterly lost without guidance. And the guidance, again, is feed it a bunch of data and tell it what to do with the data, or give it a prompt and ask it to do something. This free will element, this decision-making element, is what is the biggest concept, the biggest topic of debate when it comes down to the future of AI. Will it achieve sentience, right? Will it do things without us telling it to do those things? And my argument along all of that is, it will only do things without being told what to do those things when you've already given it advanced instructions saying, hey, listen, for the next 10 years, this is your job. This is what I want you to do, right? And I want you to optimize for this. Now, those instructions have to be so clear and so specific that we remove any adverse actions that AI tool can make. For example, if you say, I want you to optimize for getting the most powerful computer, but I want you to also keep in mind that you're not free to use up all of the resources that human beings need to survive, because you may, use all of the raw metals or the raw materials that's required to build everything for infrastructure, and all of the mining that you will do will destroy human habitats. You're not free to do that, right? I want you to optimize it, keeping in mind, very importantly, that you're not to disrupt anything that has to do with a human being's life, right? That's very specific instructions. You tell it to optimize for its job, but not optimize so much that you're going to destroy humanity, right? That's what that really means, that the instructions that you give it are extremely important. And those instructions have to do with the ethics and the morals of the human being that's giving those instructions. I'm kind of getting a little bit ahead of myself, but yeah, again, I go down rabbit holes. Just keep that in mind, right? I'm going to be talking about a lot of things that are not necessarily on the screen. So, all right. So, the distinction is very crucial here, especially in cybersecurity, where AI can spot a phishing scam faster than any human eye, but it still needs us to set the rules and to interpret the results that it generates, which is pretty much exactly what I was going to be talking about in this section anyway. So the myths that we have to deal with when it comes down to AI is so vast. People's imaginations are amazing. But this is not the myths that we have to deal with is not what Hollywood has created in the past and what people in Hollywood think about when they create these movies. So we got to clear the air on a lot of these things. So Hollywood loves to paint AI as a villain because that's what gets eyeballs, that's what gets people's attention, and that's why people talk about. So Skynet from Terminator, for example, rising up to enslave humanity, or the all-knowing HAL 9000 from 2001: A Space Odyssey, turning murderous over a chess game. Or think about the agents inside of the Matrix, right? And the robots, when you exit the Matrix and you actually are in the real world, those robot sentinels or whatever they are, that they hunt you down and they try to kill you and all. Like, you really have to think about it. Like, it's actually kind of crazy. That to me reminds me of an AI that was given bad instructions and it prioritized its own survival over the survival of humanity, and now it's using human beings as glorified batteries, which is kind of one of the premises or one of the plot lines inside of the Matrix. That like those types of things are great entertainment, but it's very unlikely that that will be the case, again, unless the human beings say, oh, this is what I want you to do, right? So these types of stories are thrilling, but they're about as accurate as saying cars are sentient because they have cruise control. AI today is narrow and task specific. It's not plotting world domination in a server farm somewhere. This is amazing to think about, really. Like, I hope some of this stuff will actually kind of help you breathe a little bit easier and be a little bit more relaxed as we go through the future developments of technology in the world and the next several years and decades come about. If the human beings that are in charge of these things are held accountable and they have the right thoughts in place, the right mindsets in place, we really will never have to worry about AI playing a villain. Another myth is that AI is infallible, meaning it doesn't make mistakes. It doesn't have the ability to make mistakes. And that's also very untrue. So it has the ability to analyze 1 million emails for spam, right? In the time that it will take you to brew coffee, it can go through 1 million emails. But it's only as good as the data that it's fed. Meaning what? If there's garbage that is fed into it, then garbage will come out of it because it's just analyzing the data that you give it. So if the training data is biased, for example, coming from one region of the world or one region of a country, then the AI might flag innocent emails as threats because the sender's location is coming from that specific or anything outside of that location, let's say. So AI won't wake up overnight, and it requires massive computing power, human oversight, and constant tweaking to even operate. This is not something, again, like, you really have to think about it. It's a very massive, extremely powerful data scraper, data organizer that has the ability to communicate the data that it's scraping and organizing and feed it back to you based on what you're requesting from it. It's not going to just wake up and start doing the things that it wants to do and then it wanting to destroy humanity as one of its goals. It's like, dude, it takes a great imagination to come up with something like that, and it's totally understandable, but again, it requires interaction for it to do anything. Debunking these myths isn't just fun for us, it's actually essential. It's necessary for not just cybersecurity, but for everything else that we're going to be doing in the world when it comes down to the use of AI. If we understand what AI's limits are, then we can use it wisely as a tireless guard dog, for example, not an all-seeing oracle from the Matrix, right? That is not what it's doing. That is not what it can do. It can indefinitely it can indefinitely scan your data. It can indefinitely scan your network and warn you of anything that's going on. It never needs to go to sleep as long as the power of the server is not taken down. You know what I mean? As long as it actually has power, then it will continue to work. As long as the chips inside of the physical server are not fried, it'll continue to work, and it'll do it indefinitely, 24 hours a day, 7 days a week, 365 days a year, 1,000 years, a millennia. You know what I mean? So this is what's really important to understand. It is not predicting the future for us, right? It can make as good of a guess as it can based on the data that it's been given, but it's not going to be this thing that will act out on its own. I can't say that enough. I just think it's one of those things that, especially for the people that are not in tech and they're worried about this kind of stuff, then this is one of those things that it's like probably the biggest concept that I want you to wrap your head around. So in the chapters and the videos, the episodes ahead, we're going to explore how to train AI, how to prompt AI, and integrate it without falling into these traps of these myths, right? Like worrying about these myths, and not just worrying about the myths, but making sure that we don't feed it garbage so that it doesn't give us garbage as output. Shifting gears a little bit, let's talk about the various AI instances in our everyday lives. Every day you use AI and you may not even realize it. It's integrated into your life. Unless you live off grid, there is a very, very high chance that you use AI several times a day. And this is, again, before GPT even came out, right? It's been woven into the fabric of our everyday lives, and it makes our lives better without asking for any kind of glorified fanfare or recognition. So as an example, for example, welcome to the Department of Redundancy department. So your virtual assistant in your smartphone. So let's say Siri, if you have an iPhone, Google Assistant, or Alexa if you use Amazon products. So when you say, hey Siri, play some chill jazz, it's not magic that is going to get responded to you. It's AI that processes your voice because, for example, when you buy an iPhone, you have to train the Siri application in your iPhone to recognize your voice only, so that if somebody else came out and said, hey Siri, open my bank account, then it won't actually open up the bank app for you. And my phone literally just recognized my voice and is trying to process my request, right? So when you say something like that, the AI actually listens to your voice and processes your voice. Then it understands the context of the command that you're giving it. So, for example, it's evening. So chill means relaxing tunes, right? And pulling from a vast music library that exists. So it will scrape through the data of all of the music library that you have access to, and it'll play anything that falls under chill jazz or jazz that is relaxing, right? It's not really complicated when you think about it like that. Behind the scenes, the natural language processing, which is a branch of AI, breaks down your words into patterns, like a toddler learning speech by hearing thousands of examples of different people talking, right? So it breaks down what you said, looks at the pattern of the request that you've made, and it then categorizes the request that you've made inside of a given set of instructions, right? So you say something, it listens to what you said, it breaks down what you said, and then looks for another data set. So think about a bunch of different data sets, like probably millions of data sets that it has access to. And one of the data sets is human language patterns. So it'll take what you said, compare it to a bunch of data sets about human language patterns, and it'll be like, oh, this series of words means this. And so I'm going to now go look for this thing that was requested from me. And it does it all in real time, which is what makes it so freaking amazing, because it's doing so many things behind the scenes in real time. Another example of this would be a recommendation engine, which is the secret sauce of any streaming service. So Netflix could be one, Spotify could be one, etc. So Netflix doesn't just guess what you're going to binge, right? It uses the AI it's been developed into it to analyze your viewing history of what you have watched and how long you watched a certain thing. So if you watched a series all the way to the end, right, versus watching a series and closing it halfway through the pilot, right? So if you didn't finish the pilot versus a show that you finished all the way to the end, or let's even take it a step further, a show that you watched multiple times beginning to end, which is something that I've done before. So it's like when you watch something multiple times, it is now being clocked into your viewing history, and you spent a certain number of hours watching a certain show in a certain category. And it'll take that viewing history and take other shows that other users have also watched that would be similar to what you just watched, and even the time of day that you logged in. And then it'll combine all of that and it'll say, based on all of this data, I think you'll find this other show interesting. And, to their credit, they actually have a really great engine, because a lot of the stuff that gets recommended to me, I'm like, oh, this is actually cool as hell. And I watch it and I'm like, this is actually dope. I really like it. So that's kind of how it all plays out, right? It's like having a friend who knows your taste inside out suggesting The Crown because you love Downton Abbey, which, by the way, neither of them I have watched. These were just examples that I found that were similar to each other. I watch a lot of anime, and I just wanted to use something that's popular with the rest of the world, because apparently a lot of people have watched Downton Abbey, and a lot of people like The Crown as well. I don't know if I make recommendations of like random anime that I've watched that people will get it. So these were examples that I think would be good examples for like the masses. Amazon does the same thing for shopping. Customers who bought this coffee also bought. You have definitely seen that, right? Customers who bought this also bought. And it's on the page of the product that you're looking at in that moment. This is collaborative filtering, and this is an AI technique that spots hidden connections in data. And finally, we have the GPS, which is probably one of the oldest tools that has been developed that has made our lives extremely easy. When I say oldest, I'm talking about relatively old. It's not, decades old. I think it might be decades old, actually. It's at least a decade old, I should say that. Google Map doesn't just plot routes. It predicts traffic jams by crunching real-time data from millions of phones, adjusting for accidents or rush hour. And this is, again, another one of those really handy things about GPS. This was not something that existed at the beginning of Google Maps, right? It's something that was developed as they further developed the application. In one specific study, AI-powered routing saved drivers an average of 20 minutes per trip in urban areas. These are not flashy inventions. They're just quiet revolutions which prove AI excels at scaling human smarts to handle overwhelming information. And this is extremely handy. Before GPS came out, you had to rely on your dad or uncle or grandfather's advice saying, hey, listen, don't take this route, right? At this time of day, this route the bridge is really busy. You don't want to take the bridge. You want to go take this out. You had to rely on stories that were transferred to you by other human beings, and then you had to learn the secrets from those types of stories. And if you didn't have access to somebody that was like that in your life, you were SOL, right? Out of luck, because you don't have access to somebody that has the wisdom because they've experienced the world, etc. It's really crazy when you think about it. Before the internet, before technology advanced to the way that it is for the last 20 some odd years, people were using actual maps, bro. They were looking at actual paper maps and they were routing their path, and somebody would chime in and would be like, oh, don't take this because this path is da-da-da-da-da. Or they would have to listen to radio reports saying that, oh, yeah, there's construction going on. This is the way that people live their lives, which is unimaginable if you really think about it. But that's the way that people live their lives. And now it's like everything is so convenient and we don't even realize how convenient it actually is for us. Okay, so to make sense of everything that we just talked about, we need to look at some key concepts, and we're going to talk about them in plain English without a bunch of complicated math and algorithms and things like that, right? To really wrap your head around AI, you just need a handful of core ideas. You need to understand a handful of core ideas and how they interconnect with each other. So first, it all starts with data, right? It's the fuel. AI thrives on data. Think about emails, images, sensor readings, or transaction logs, any kind of data that comes in, right? Sensor readings could be sensors that feed its data to the AI, right? There's data being processed into your brain right now as you're watching this. There's at least 2 to 3 sources of data. You're watching this, you're listening, and you're probably clicking around on your phone or something. You might be taking notes. There are at least 3 or 4 different sources of data right now, and we're not even talking about all of the historical data that's stored inside of your brain that you're using to establish your own perspective and concepts and all conclusions and all of that stuff. We're not even talking about that. We're talking about the data that you're being fed in this immediate moment as you're watching this, right? Your brain is a really complex computer, and so it also thrives on data. Everything starts with data. The more diverse and clean the data, the better the results are. In cybersecurity specifically, data could be network traffic logs, and the AI will hunt for unusual spikes that scream intrusion, right? Inside of network traffic, there's something called a baseline, or really inside of any kind of logs inside of computing, there's something called a baseline, which is normal activity. And anything that falls outside of that normal activity is something that can generate an alert. And the AI, but even before GPT, so again, there's just so many different versions of this that existed before GPT. The AI or the algorithm will be like, okay, this is what the normal data is supposed to be, and there's something that's weird about this current set of data. I need to generate an alert, because if data is out of the ordinary, my job is to generate an alert. That's basically what it is. The next piece are the algorithms. So this is the brain's wiring. So going back to the brain example, you have a bunch of synapses that are firing inside of your brain and combining all of the data that you're receiving and trying to make sense of all of that data. So the simple algorithms follow if-then rules. If this happens, then do this. That's basically the most simplest form of an algorithm. But then inside of that one rule, there could be a bunch of other if-then rules. So you could literally have one major if-then, then there is a subcategory and another one inside of that. So now you have 3 layers of if-then rules. So if an email has urgent invoice, flag it, right? That could be one of the rules. Very, very basic. If an email has this, then do this. And something could happen in your home, in your everyday life, where if my clock rings, then I gotta wake up. If my phone alarm rings, then I gotta wake up. If I'm feeling too tired after my phone alarm rings, then I'll click snooze and I'll wake up in 10 more minutes. If I don't wake up on time, then I'll be late to take my kids to school, right? So there's a bunch of different if-then rules that are working just to do one little thing inside of your mind. The advanced algorithms, like neural networks, for example, mimic the human brain, hence the name neural. So neural networks mimic the human brain with layers of interconnected nodes that learn by adjusting weights based on errors. It's like teaching a child to ride a bike. Trial, error, nudge the handlebars, repeat until balance clicks. So this is what it means. A weight for an error, just to think about it, right? It's like this particular error has how much weight, how much damage was caused based on this error. If it has low weight, it's not that big of an error, so we just need to make a little nudge. If it is high weight or heavier, right, then that was a really big error, and we need to make a big shift, right? So it makes adjustments based on the weight of these errors. And very, very similar, this is probably the greatest example we could come up with, is the child riding a bike, right? The first time you get on a bike, you fall immediately. The next time you get ahead 2 feet and then you fall. The next time you get a little bit further and you get a little bit further until you're kind of like squiggling along and keeping balance. And then ultimately you get to the point where you actually have real balance, right? And just trial and error. And throughout that process, you gotta kind of scrape your knees a few times, scrape your hands a few times. You get a couple of bruises, but those bruises are the big weighted mistakes that resulted in such a heavy error, because now you actually have your knees bleeding or whatever. Those types of errors are the ones where you're like, well, I'm definitely not doing that again because that really hurt, right? So this is how algorithms in neural networks with AI also work. And finally, we have automation. So data fed through algorithms, and once the algorithm has really tweaked and optimized itself, then automation can take place. And that is called training. So once the AI, through those neural networks, through the processing of data, through the error resolution, once it's gone through all of that, it is now trained, and now it can actually run on autopilot. And a model is the end product. So this is a compressed version of the algorithm plus all of its data insights, and it's ready to make predictions once it's been prompted, right? So it's not going to do it by itself. It needs to be prompted. The training is the gym session. So you feed the model examples. For example, labeled spam emails, so actual spam emails in the past. You feed it a bunch of spam email examples, and you say, okay, based on these examples, I want you to be trained so that you know what to look out for. Then you practice, you let it practice, I should say. And then as it practices and runs with new emails that come in, it refines its processing, it refines its filtering process. And inference is showtime. It's basically the real life scenario where the model applies its knowledge to new data that's coming based on its previous data that was fed into it, like scanning an incoming message in an email. So the model itself, right, is trained on practice data, and once it has enough data and enough of a frame of reference, then we can do inference. That model can actually infer in real life situations and start making predictions based on all of the data that it was fed before. All of these pieces fit together like Lego bricks, and in our specific course that we're dealing with, we're going to be experimenting with these different pieces, starting with no code tools in section 3. And then for now, we're just going to know that there's a toolkit for turning chaos into clarity. So that's basically what it is. Think about billions and quintillions and cajillions, trillions of data points, which is there's so much data. Think about all of that, and think about how insane it would be if you had to sift and sort through that, and from there make a decision. And think about an AI model doing it for you in seconds, right? It's insane when you really think about it. It's so powerful when you really think about it. And then the last piece of it is it's not going to do it without you, which is why it's your friend, right? Now, switching gears a little bit, let's talk about some of the history of where we were and how we got to where we are. Because this was not just an overnight thing, where a couple of years ago, right now it's 2025, so I think like the first version of GPT came out in 2023, I want to say. And it didn't all just start in 2023. As you already know, GPS, as an example, has been around for easily over a decade. I want to say probably 20 years at this point. And now we are where we are. So it started in the 50s. So believe it or not, it's 70 years ago now, 75 years ago. And this was post-war optimism about machines. And in 1950, there was a guy named Alan Turing who ultimately developed the Turing test. And the Turing test would be, could a machine fool a human into thinking that it was another human through conversation? So when you have a conversation with it, could it pass that test and you don't think that you're talking to a machine? And this sparked the field, with 1956 Dartmouth Conference coining artificial intelligence and promising machines that could use language, form abstractions and concepts, solve kinds of problems that are now reserved for human beings. And if you can imagine, during those early years, there were not very many people who supported this idea or even believed that it was feasible. So AI winters happened very frequently, which basically AI winter is when droughts of overhyped promises implemented funding, right? The funding to make these types of technologies become real were every once in a while there would be a drought where there would be a lack of funding because there were a lot of promises that were made and earlier delivery times, right, that never actually happened. Therefore, the funding was cut off. In the 70s and 80s. So imagine we've gone from the 50s and now we're in the 70s and 80s, which is several decades later, where computers lack the power for big dreams because, I mean, the first official personal computer was in the late 90s, right? So breakthroughs were still developing. In 97, IBM's Deep Blue stunned the world by defeating the chess grandmaster Garry Kasparov, showcasing search algorithms that evaluated 200 million positions per second. And chess was a very small win in relation to everything that was going on, but it proved AI could outthink experts in rule-bound games, right? Because there are patterns, right? If it has all of the patterns inside of its database, based on the moves that you have made, it can now start to make its own decisions because it can predict what you're going to do, right? The 2010s ignited the very first official boom, like the modern version of the boom, which was fueled by cheap data, meaning data generation, data processing, and storing was not expensive to do anymore. And cloud computing became a bigger element as well. And graphics cards, graphics processors, also known as GPUs, that are typically used for gaming because games on computers require strong graphics cards to actually display the visuals on the screen and do it in a real enough time where the game doesn't lag, right, and it doesn't glitch. So there were some of this more powerful elements of computing that were generated, and they were generated for gaming, but then they started being used for computing for a variety of other things. For example, mining cryptocurrency these days, and of course, powering the computing power of AI models. In 2011, IBM's Watson crushed Jeopardy champions by understanding natural language and trivia's nuances. In 2016, brought AlphaGo, which is actually a Go is apparently like a really complex game, and DeepMind, which now works with Google, I want to say, bested the world Go champion, and Go was a game so complex that it dwarfs chess, requiring intuition over brute force. AlphaGo learned by playing millions of games against itself, which was a hallmark of reinforcement learning. It was one of the key developments of data or AI learning from its own data that it's doing over, countless iterations of a specific task. And by the 2020s, generative AI exploded. So we had things like GPT models, which were developed by OpenAI, DALL-E, which was also developed by OpenAI, or I guess eventually purchased by OpenAI. I don't know actually what the history of DALL-E is, whether or not they started as an independent company or they were just a part of OpenAI. I want to say they were it started out originally as a part of OpenAI, and it created text, code, and art from prompts, trained on internet scale data. So GPT was very much so a game changer, and we have our lovely friend Elon Musk to thank for that, because he was the one who co-founded and spearheaded OpenAI, and it originally was supposed to be open source AI that was supposed to be available for free or at extremely low cost to everybody, but ultimately it was acquired by Microsoft, and now it's a for-profit company, as we all know, I'm sure by now. As of right now, at the time of this recording in 2025, which is what's today? Today's September 2025. September 20th, 2025 is when I'm doing this recording. As of right now, we're seeing AI agents that not only respond, but they act. So, for example, book flights for people or draft reports for people. In cybersecurity, this evolution means tools that don't just detect threats, but they can predict and neutralize them on your behalf, like an AI that simulates hacker moves before they actually happen. Very, very powerful concept. This history isn't dry facts. It's a reminder of human ingenuity. AI fathers like Turing dreamed big. This was 75 years ago. But it's everyday innovators like you and me who are going through this who will shape the future. And right now, if you were to have an interaction with Grok, right, on a chat platform without knowing that it was Grok, right? If there's no voice that you have to worry about, and if there's no video that you have to worry about, if you're just chatting with Grok without knowing that it's Grok, right? So you don't know that you're talking to an AI model. If you chat with Grok, you will think that you're chatting with a human being, which means that the Turing test has been passed. And I would say that it was passed several models ago, honestly. But right now, as it stands, when you're chatting with one of them, it's very, very, very obvious that that model can pass the Turing test. Now, speaking to an AI could be a little bit different, but that's also becoming extremely, like eerily good, because chatting with Google Gemini's application, it can talk to you normally. There's no robotic voice or anything. It's like a beautiful, I mean, you could choose the voice that you want, right? So you could have like a beautiful British voice or an Australian voice or an American voice, whatever. So there are so many different things that now they're like, oh my God, it's kind of odd. If I didn't know that I was chatting with an AI, I would kind of assume that I'm chatting with a human being, which is passing the Turing test. And once it gets to the point that, I mean, there are so many things that it can already explain. One of the big things was, can it actually explain a complex topic? For example, what is love, right? Maybe it can't explain that. Maybe it won't be able to wrap its head around that, but it has such a massive data set that of course it can explain love based on the scripts from a bunch of different rom-com movies, right? It can be like, oh, this is what love is, right? So it all depends on how you're communicating with it, whether or not you'll think that you're communicating with an AI bot. And now check this out. There is now various services that have been developed through AI, which requires that if you call a company for customer service and an AI answers, it has to say that it's AI, because it's so indiscernible from a human voice that you might think that you're actually talking to a human being. So they have to disclose to you that, no, I'm actually just a help bot. If you want to talk to a real human being, I'll transfer you. But really though, who wants to talk to a real human being if the bot can actually do as good of a job and do it faster and still take care of you, right? So it's like, at what point do we really need human beings? Which is why at the very beginning in episode 0, I mentioned that, okay, repetitive jobs are going to be handled by AI, and they're already being done. And a repetitive job is what? Somebody calls customer service, or they start a chat with customer service. And if it's in the context of my cell phone plan, there's only a handful of questions that I can come up with for that specific conversation. So all of those questions are going to be pre-fed into the data set of that model, and it's going to know exactly what all of the answers would be and what all of the variations of the conversation would be. Am I a disgruntled customer that I'm pissed off and I want a fee, or do I just want to make modifications to my plan, or et cetera, et cetera. So it's so easy to do that. And same thing with chatting over voice, and same thing with texting and all of that stuff. So there's a lot of stuff that they're already being outsourced to AI because it's just so repetitive. These conversations are so repetitive. So what it comes down to is, what are we going to do as the people who are excited about the future of AI? How are we going to modify, implement, utilize, advance AI so that we can do much more complex tasks and achieve much more complex goals, because the repetitive stuff is going to be outsourced and automated. It's already been outsourced and automated. So now, connecting all of this stuff to our topic, which is cybersecurity. Again, this channel is about cybersecurity. So connecting all of this to cybersecurity, we need to look at a few different goals that can be accomplished through the use of these powerful tools. So our digital lives, if you don't already know, if you're not getting a bunch of spam text messages and spam calls already, our digital lives are a battlefield. Hackers launch 2,200 attacks per day per a recent IBM report, from phishing lures to ransomware that locks hospital files. Recently, the DMV in Las Vegas was hacked, right? Traditional defenses like firewalls or antivirus rely on humans to spot anomalies, but we are outnumbered. And the rules for these things are also very rigid rules, right? A firewall says block all of these things, allow these things. That's very rigid. Antivirus looks for signatures inside of a file and says, okay, this signature matches this other thing. I'm going to assume that this is a virus. We're going to block it, right? These things have very strict, rigid rules. So AI will come into play, and it processes petabytes of data, right? That's a lot of freaking data, because we've graduated from gigabyte to terabyte to, I think petabyte is after terabyte. I'm pretty sure it's a giant amount of data. It processes all of that in seconds, and it uncovers threats invisible to the naked eye, because human beings are just, you get tired. Right now my eyes are kind of burning because it's getting a little bit later into the evening, and I have this light in front of me that's kind of bright in my eyes. So that's one reason why my eyes would be tired. It's later in the day, so I'm kind of running low on fumes as far as energy is concerned. So my brain is a little bit tired. So you know what I'm saying? So there's so many different reasons why human beings can make human error, but AI will not. So as an example, let's talk about phishing again, right? These sneaky emails that pretend to be your bank, right? Click here to verify your account is one of these freaking emails. Or I get a lot of text messages from Coinbase saying that your authorization for a transfer has been granted. This is your authorization code. If you did not authorize this, call this number, right? And it's like, okay. And I get that at least several times a day. And I'm like, okay, bro, I never authorized the transfer. I have several forms of authentication, several layers of authentication for my account. There's no way in hell that anybody has requested a transfer to leave my account, to leave my wallet. Like, it's just so crazy to think about, but that counts technically as phishing. It's smishing because it's coming from SMS, but it technically counts, right? And they're transferring you to a voice phone number, which goes into vishing, which is voice. And so they have this like elaborate scheme that's going on just to try to socially engineer you. Now, AI will scan for these types of tells, so odd grammar from non-native scammers, mismatched domains, or links to shady servers, if we're just talking about emails. Gmail's AI, for instance, blocks 99.9% of spam using machine learning that evolves with new tricks. And to their credit, there has been, I rarely, if ever, get an email in my Gmail account that I'm like, oh, this is spam, or it's phishing, I should say, right? This is phishing. Then I do get spam, because there are ways that people can just send me an email requesting me to apply to something or whatever. However, it technically doesn't count as phishing, right? Gmail will actually detect phishing, and it'll detect like very blatant spam, and it'll block all of that. So very, very, very powerful email platform. Obviously, I mean, I think most people that I know have Gmail. Maybe like 99%, 98% have Gmail. Some people have MSN or Hotmail still, or some people have Yahoo still, but most people that I know have Gmail. And in one case, it caught a spear phishing campaign targeting executives by analyzing email rhythms. Humans write with subtle pauses, bots don't. So this is all Gmail's AI that filters phishing emails. Fraud detection is another one. This is actually a really big win in AI for cybersecurity or security in general. So credit card companies use AI to build your normal spending profile. So again, referring back to the baseline, right? So this is the normal type of spending that this person does. They visit their gas station once every couple of weeks. They go to these different stores for groceries inside of this region. They spend on average $125, etc., right? Once it has all of that stuff, then what it'll do is that it'll look for anything outside of that baseline. So for example, a $5,000 watch purchase in Paris when you're in Seattle or Las Vegas or LA or whatever, it's like, oh, this doesn't seem right. Literally 5 minutes ago, they just bought gas in Las Vegas and now they're buying a watch in Paris. Okay, we're going to hold this transaction, right? And then they're going to text you, or somebody's going to call you, or they're going to email you something, some kind of notification is going to pop up and it's going to say this transaction was blocked. If you want us to process the transaction, you need to verify it. And that's the power of AI protecting your finances. It's amazing. So this is considered an anomaly. Anything that falls outside of the baseline is an anomaly. And this saved billions of dollars in 2024 alone for Visa, just for Visa, right? We're not talking about MasterCard, Discovery, Amex, none of those stuff, just for Visa, right? AI doesn't just react, it anticipates. It learns from global patterns to flag emerging scams like deepfake voice calls. And I get a bunch of those per day as well, where it's like I get a call and there's a little note under it. It says likely spam or whatever the message is. Likely telemarketing, right? There's just so many different implementations of this where it's like, wow, this is actually really useful and it's really powerful. And when you think about that, you start to become more receptive and more welcoming to AI being in your life, don't you? Because it's already saving so much in your life. It's saving you time, energy, saving you money, saving you headaches and heartaches, so many things. In essence, AI turned cybersecurity from a game of whack-a-mole into strategic chess. It automates the grunt work, it lets us focus on strategy, and to keep in mind some of the key elements of this, just to make sure that you're in the right headspace, is very important, right? The myths themselves. So AI needs diverse data to avoid biases, like over-flagging emails from certain regions, and ethical training of the AI is very important. And we're going to be talking about this as well. It's non-negotiable. This is one of those things that you cannot cut around, right? You need to have ethical training of these things so that there are no biases, right? AI being biased is not useful. AI being biased is dangerous. It can flag certain things that it shouldn't. It can prevent certain groups of human beings from getting access to equal resources. There are so many reasons why getting ethical training for an AI bot, an AI model, is so important. And this is where a lack of bias is the most important. You want to have a bipartisan type of an AI. You don't want to have something that leans a certain way on any topic, right? This is very, very, very important, especially when it comes down to social topics, right? Science and math are a little bit easier because science and math have very rigid rules. Physics has very rigid rules, and trying to lie about the laws of physics is almost like ridiculous. It's like if an AI is hallucinating or lying about the laws of physics, then that thing should not even be up and running, right? I understand if it tries to make certain decisions or certain comments about political landscapes because for whatever reason it was fed a certain type of data and so it responds based on the data that it was fed. That I understand. But when it comes down to math, when it comes down to biology, chemistry, coding, any of these things, there should be no mistakes. And that's one of the key things that I expect from AI tools is that if it's facts, if we're talking about physics, if we're talking about mechanical engineering, there should not be any mistakes, right? You should at least give me, based on all of the data around mechanical engineering, you should be giving me really solid responses. If I'm asking you about something that's opinion-based, like what's the best comedy movie of all time? It's like, okay, well, it can't process comedy, number one. It doesn't really have a sense of humor unless it's been trained on a bunch of jokes, which one of the reasons why I like Grok so much is because it actually has like a really solid sense of humor. But again, it can't really make a decision on the best movie of all time because that's such an opinion-based question. And what it thinks is the best movie of all time may not necessarily be what I think is the best movie of all time. So this is where science-based, fact-based questions are really important and they should never be incorrect, right? Unless there are new developments in physics. But opinion-based stuff, that should be the stuff that it's like, okay, well, I'm going to gather everybody's opinion. I'm going to gather everybody's feedback in the ether. And from there, I'll tell you what the consensus is across the board, and then you can make your own decision, right? That's the kind of stuff that we need to talk about when we're talking about ethical training. That data needs to be from everywhere, from every human, from every source, so that it has the most complete amount of data. And once it processes it, the rules inside of its algorithm as it's processing should not be limited to if somebody asked about this politician, respond this way. And then if somebody asks about this other politician, respond that, like, it shouldn't do that. It should just say, this is what the ether is saying. This is what the consensus across the board is, right? Or at least give you facts about, okay, this is what happened that day, that kind of stuff. But opinion-based stuff, that's kind of the stuff where like a lot of the gray areas come in. All right, let's run our first little experiment. So here's just an example, and then I'm going to give you an actual query that I want you to run, and I want to see what the response is that you will get when you run it and how it will compare to what I'm going to run right now. So the theory is amazing, right? We just want to practice this in real life. So imagine firing up a chatbot like Grok, for example, from XAI or ChatGPT or Google Gemini. I'm going to end up using Google Gemini because it's just in my browser right now. But again, I'm just very curious as to what the response is that you would get based on what you used, right? The question is supposed to be typed the exact same way. That's the key element here, is that we're going to give it the same exact prompt, and what we want to see is how these different things respond. And, you know, I'm very curious if your response from Gemini is going to be different from my response from Gemini. That's very, very important for me too. It's also like, I think it's important to test different AI models, but I also am very curious how the same prompt will generate a different response from the same exact model. That part is also really interesting. So for example, in this particular case, if you went to say, you know, explain what a phishing email is like I'm 5 years old, and then see what the response will be in just a few seconds, you'll get a tale of trickery fishermen with fake worms to hook your info and complete with tips to spot those types of emails, right? That's called inference, the AI drawing from its training to simplify complex ideas. So now let's actually take a practice query that we're all going to end up using, and then you're going to tell me what your response was. So I want you to tell me what model you used and what your response was. The example is going to be, how does AI stop hackers, right? That'll be the query that we're going to give it. And we want to see what kind of a response we're going to get. This is as close to playing with these things as we possibly can get. And I'm really, really excited to see the response. So what I'm going to do right now is I'm going to use it in x.com Grok as well as Gemini, just to see what the response is going to be on both of those tools. And then I'm really curious as to the types of responses that you would get. And just to make our lives a little bit easier, we're going to take the first paragraph, let's say. We'll take the first paragraph that you would get from a response, because this is a little bit of a complex response here, or a complex question, so I can't imagine that it would give you a long response. So what we're going to try to do is just take the first paragraph of the response that you get, and then from there drop it in the comments just so we can see what it is. So you're going to tell me what model you used, right? If you use Grok, or if you use Gemini or GPT or whatever, and then from there tell me what the response was to the question. So how does AI stop hackers is going to be the question. So let's try this out right now. Let's go to Google Gemini, and I'm going to go ahead and start a new chat, brand new chat. So there's no frame of reference. There's no previous commands or anything, like no history previously. And what I'm using is the 2.5 flash version of Gemini. So if you're going to use Gemini yourself, use the 2.5 flash version, because I really want to see how close the responses are going to be. And then I'm going to paste the question. So how does AI stop hackers? I'm going to press enter, and then we're going to get this response in just a few seconds, right? So here we go. The top, it says AI stops hackers primarily by using machine learning to analyze vast amounts of data, to detect and respond to threats in real time, often more quickly and accurately than humans can. Instead of relying on predefined rules, which can be easily bypassed by new attack methods, AI systems learn to recognize the characteristics of both normal and malicious behavior. Normal being baseline and malicious being anomalies, right? How AI detects and prevents attacks, yada, yada, yada. So this is the response that I got from Gemini. So now let's go to x.com, and then we're going to do Grok's response. So let's see what Grok's response is going to be in this particular case. Or actually, it's not supposed to be Grok like that. I think I'm just going to say Grok AI. Let's do that. So x.ai, my bad. So x.ai, my bad. So that's the website. So paste the question, how does AI stop hackers? Press enter. Let's see what we get with this guy right here. So the first one, AI stops primarily from machine learning, etc. So let's see what this thing says. AI stops hackers by enhancing cybersecurity through several key methods, leveraging its ability to process vast amounts of data quickly and identifying patterns. Here's a concise breakdown: threat detection and prevention, behavioral analysis, automated response, phishing and social engineering defense, right? So there you go. So immediately, just from surface level, you can actually see the difference of the introduction. Now, here's what's interesting, right? So as it gets into its data right here, as Gemini gets into its data, it says threat detection and behavioral analysis, phishing and social engineering prevention, malware analysis, automated response. Those are the top 4 bullets. This one says threat detection and prevention, behavioral analysis, automated response, phishing and social engineering defense. Phishing came 4th, right? When on the previous one, it was the 2nd bullet. So you can see there are through lines, there are similarities to this, but then there are also pretty big differences in the way that it breaks it down. Now, here's what is kind of, it should inspire confidence, right? These things, when we're asking about something that has to do with science, right? It's technically hacking has to do with computer science. So when we're talking about something that has to do with computer science, we will get hopefully similar responses. Now, if I go over here and let's do one more time. So we're going to refresh the page, right? And I'm going to reload this and hopefully it'll just clear the page. There we go, because I'm not signed into my Grok account. So now I'm going to say, what is the greatest comedy movie of all time? Now, this is a opinion-based question, right? We're going to ask that from that, and then we're going to go to Gemini. We're going to start a new chat here, and we're going to say the same thing. What is the greatest comedy movie of all time? So let's see what AI said. AI for Grok, excuse me. Short and sweet, right? Small. So this is actually probably the better question. What is the greatest comedy movie of all time, right? So I'm curious as to what the response would be for this question for you as well. So the greatest, quote unquote, right? The greatest, quote unquote, comedy movie is subjective. Great answer. But Monty Python and the Holy Grail from 1975 often tops the list for its sharp wit, absurd humor, and timeless quotability. Its low-budget charm, clever satire of Arthurian legend, and iconic scenes like Black Knight and the Holy Hand Grenade have made it a cultural touchstone. Posts on X and web rankings frequently cited as a standout, with IMDb and Rotten Tomatoes users score consistently high 8.2 out of 10 and 97%. And other strong contenders include The Big Lebowski. I love The Big Lebowski for its quirky characters, and Groundhog Day for its heartfelt hilarity, but Holy Grail's influence and enduring fan base give it the edge. What's your take? Got a favorite comedy? See, now it's actually asking me for my opinion just so it can add it to its data set. So let's see what this thing said. Look at this. This is a much larger response. So this is the Gemini response. Greatest is subjective. Excellent. There's no single universally agreed upon greatest movie of all time. Excellent. So classic comedies. Some Like It Hot, Dr. Strangelove, Annie Hall, right? Parody and satire, Airplane, Blazing Saddles, Monty Python and the Holy Grail. Excellent. Modern and cult classics, Groundhog Day, This Is Spinal Tap, The Big Lebowski. So you see the through lines, right? Even with something that is as opinion-based as comedy, right? It still gives you really good responses because what? It's actually pulling from a bunch of data online, for example, blogs and forums and Rotten Tomatoes and all of that, right? So really, really interesting to see these kinds of responses, and I hope you actually try it out. So just let me know which question you used, which model you used, and what the response was. Probably the first one, which is how does AI stop hackers? I think that's an interesting one, and probably the response is going to be exactly this or very similar to what I got. I'm just curious if you're going to get like different paragraphs as the intro. I'm sure the idea will probably be the same, but I want to know if the phrasing of the paragraph is going to be different. And same thing with the greatest comedy of all time, right? So what is the greatest comedy movie of all time? And if the ranking is going to be any different from the ranking that I got. To wrap it up, the foundation has now been laid. You now have a strong foundation set. So we've covered that AI is a pattern spotting powerhouse, debunking Hollywood halos, spotting it in your applications, grasping its lingo and lineage, and seeing the cybersecurity shield in action. AI learns from data via algorithms to automate smarts. Think super librarian for threats, and it's already your ally against spam and scams and fraud. And its history proves that it's here to stay. So now I want to give you a quick little question. So here's a quick little quiz for you, actually. So we have 4 questions. What's an example of AI in everyday life? True or false, AI can feel emotions? Name one 2010 AI milestone, and how does AI help with phishing? The answers are not going to be provided in this video because these are very, very easy questions, and I just want to make sure that you watched the video and paid attention to what's going on. So feel free to, if you want to, go ahead and respond to these questions in the comment section below, because there are different examples, right? You can come up with a different example of AI in everyday life that we didn't talk about today. This one is pretty straightforward. It's either true or false. Name one 2010 AI milestone, which you can refer to by either Googling or just reviewing the contents of the history portion of this video. And how does AI help with phishing? That's also something that you can answer either by actually asking AI how it helps with phishing, right? Go ask Grok, right? How does AI help with phishing? That could be a really easy way to get an answer. And then based on that, see which ones you actually got right? So 3 out of 4 right, then you're pretty solid. 0 out of 2 or 0 to 2 right, I should say. Then you need to kind of review this again. But again, this is not like a big deal. It's not like a big question. There's no actual examination or something like that. I just want to see if you kind of retain the information. This type of stuff helps to recall the information you just got and hopefully help you retain it a little bit more. Thank you so much for joining me on this special first episode of our AI for Cybersecurity training series. I really hope you got some value out of it. It's just going to get more technical and exciting as we move forward. And if you have any questions, please drop it in the comment section below. Make sure that you like, subscribe, and turn on the notification bell. And of course, if you are considering joining Hackaholics Anonymous, here's a first download that's going to be available to that group, which is the AI Glossary. And there's going to be more than 50 terms, analogies included, and the AI history infographic that will be available inside of the Google Drive that we have shared for everybody, so that you can either print it and put it on your wall or your desktop, or of course, use it for studying methods. And that was it. Just like that, we wrapped episode 1. So again, hopefully you got some value out of it. Make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that an episode comes out on this channel for this training series. And of course, there's a bunch of other training series that are being launched every single week. So make sure that you stay tuned for all of that. Drop a comment if you have any questions in the comment section below. And very much so, consider joining Hackaholics Anonymous. The link is going to be in the description below, and you're going to get a quick little message as to what all the benefits are that you would get if you actually joined Hackaholics Anonymous. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. That's kind of my little tagline. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next episode later. If you want access to my notes and exclusive downloads, and to get lifetime access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers. We have the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, and you will be able to choose the tier for which you want to join. I really hope I see you in the Discord chats. If not, I hope I see you in the comment section.